Welcome to aminacademy.com. In physics regarding sound, let us do some solving problems. Look at this example. An argon pipe whose length is held constant resonates at a frequency of 224 Hz when the air temperature is 15 degrees Celsius. What will be the resonant frequency when the air temperature is 24 degrees Celsius? Here, two different temperature is given. Regarding that, the frequency is changing. We have to find the frequency. Look at here. For this, first, the resonant wavelength must have the same value at each temperature because it depends only on the length of the pipe. That means the wavelength is only depends on the length of the pipe. The frequency only changing when temperature is changing. That means its nodes and antinodes must fit properly within the pipe. We know that lambda equal to V by F, that is speed by frequency. Then that is must be same at the two temperatures. Therefore, look at here, V1 by V2, the ratio is equal F1 by F2. These are ratios. Then we have to find F2. F2 equal V1 by V2. F2. F2 equal F1 into V2 by V1. That is F1 is 224 into here regarding the temperature, that the speed of the sound is changing. The first, that is V2 is 15 degrees Celsius. 15 degree. Now V2 is 24 degrees Celsius. Therefore, which changes as 331, that speed of the sound, and 0.61 into 24 degrees divide same 331 plus 0.61 into 15 degrees. So by using this calculation, we have the frequency. The second frequency is 0.228 kilohertz. That is 228 hertz, which is converted to kilohertz. This F2. Next question. The sound has intensity of 3 into 10 power minus 8 microwatts per meter square. What is the sound level in decibel? Here, the sound has intensity 3 into 10 power minus 8 microwatts per meter square. What is the sound level in dB? Your sound level in dB, the formula is equal beta equal 10 log of intensity over 1 into 10 power minus 12. Now this is further equal 10 log. Intensity is given as 3.0 into 10 power minus 8 over 1.0 into 10 power minus 12, which is equal 10 log here 3 3 3 into 10 power minus 8 over 1 into 10 power minus 12. This minus will go up as plus 12. So it's 10 power 4. 3 into 10 power 4, which is equal 10 into, here log of 3 into 10 power 4 is, that is 4 is for power plus log 3. Log 10 power 4 is 4 and log 3, which is equal 10 into 4. Log 3 value is 0.477, which is equal approximately 44.8 decibel. Here, in decibel, what is the sound level in decibel of that intensity of the sound is 3 into 10 power minus 8 is here 44.8 decibels. Next one, two sound wave have intensities. Two sound wave have intensities of 10 and 500 microwatts per centimeter square. What is the difference in their intensity level? Here, 10 microwatts per centimeter square for sound A, for instance, sound A, second sound B. Then this is intensity is, or I is 10 microwatts per centimeter square. For sound B is 500 microwatts per centimeter square. Now, therefore, beats A, beta A is 10 log decibel, 10 log IA over I0, and here beta for B, sound B is 10 log IB by I0. So here you can write this as 10 log A by B is 10 log IA minus log I0. This side is, sound for B is 10 log IB minus log I0. Here, the difference of bits level, beta B minus beta A, which is equal 10 of log IB minus log IA, which is equal 10 times log of IB over log of IA, which is equal 10 times IB is 500. Both are same units, microwatts per centimeter square. Here also microwatts centimeter square. This is by 10. So, which is equal to log, that is 500. without cutting into, that is 10 by 10. Then now log of 500 by 10. This cut here, therefore which gives 10 log 50, which is equal 10 into log 50 is 1.70 by table, which is equal 17 decibel. So that is here that intensity level is changing from 10 to 500 microwatts per centimeter square. Its decibel changes up to 17 decibel. Therefore, the intensity level, the difference in intensity level is 17 decibel. Next question. One typist is furiously typing in a room gives rise to an average sound level of 60 decibel. What will be the decibel level when three equally noisy typists are working? Here, each typist emits the same amount of sound energy. Therefore, the sound intensity IF final should be 3 times the initial. That is intensity in initial, then IF intensity at final intensity. Then B final, that's B's sound level, if equal log of I final minus I initial, which is further equal log M by N is log I final minus log I initial, then which is equal, therefore log of, therefore B final, this is B final means B final minus B initial. Therefore, B final is equal beta initial plus log of I final log of I initial. Now, look at here, that is BI plus log of I final minus I initial, which is equal 60 is already one typist decibel level is 60 plus log of the difference is IF by I. This is a, what will be the decibel level when three equally noisy? Equally noisy means this IF by II is 3, which is equal 60 plus log 3 value is 0.5 approximately. This is log 3 is 0.5. Then you check log 3. Better 0.47, 0.477, which is equal 60.5 4.60.47 decibel. The sound level, being logarithmic measure, rises very slowly with the number of cycles. Next question. An automobile moving 30 meters per second is approaching a factory whistles that has a frequency of 500 hertz. First one, if the speed of the sound in air is 340 meters per second, what is the apparent frequency of the whistle as heard by the driver? Next one, repeat for the case of car leaving the factory at the same speed. This first is approaching, second is leaving. Here, F0, this is by Doppler effect. F0 is Fs V plus V0 minus V minus V minus Vs. Here, this 500 is whistle has 500 hertz. That is speed of the sound in air is when not moving. That is 340 plus speed of the sound in air plus 30. Why this 30 meters per second? Because 30 meters per second, one automobile moving. Divide 340 minus initial speed is 0. Then that is starting from rest here 0, which is equal 544 hertz. That means that is the vehicle is approaching a listener, so it's increased, that it's apparent increase, that is it becomes 544 hertz, frequency is 544 hertz. Next, then second part, when leaving, that is vehicle is leaving from the listener, the same which gives F0 equal Fs V plus V0 over V minus Vs. Here Fs is 500 hertz, here 340. This is leaving, V0 becomes negative now, plus minus 30 over 340 minus 0, which is equal 500. That is 340 is 310, because 340 minus 30 over 340, which gives 456 hertz. That means when vehicle approach whistling and approaching the listener, so its frequency, sound frequency of the sound is 544. When it is leaving the listener, its frequency is 556. You have 544 500 into 310 divided by 340. So frequency is changing here. We have done. Please subscribe our YouTube channel.